Okay, so we're going to continue our study on inverse functions, and we started looking in previous lessons regarding finding the inverse of a function. And sometimes it will say things like find the inverse of a function symbolically or algebraically, and that's going to be the focus of this lesson. So it'll be just more problems involving finding the inverse. Now, before we go on, and this is going to be important in our discussion, in one of the previous lessons, you learned that, and we looked at in terms of a linear function, you learned that when we have a linear function, the inverse undoes what the linear function does. So what f of x does, its inverse will undo. So notice that for the function f of x, the x and y coordinates. So notice that the x coordinate is 0, the y coordinate is -1. For the inverse, it's just the reciprocal. Not the reciprocal, it's just the other way around. So the variables or the coordinates are reversed. So notice that when x is -1, y is 0. So when we talked about functions and its inverse, and then the fact that the inverse undoes what the function does, we interchange the coordinates. So the x became y. You see that? The x, 0, -1, 1, -1 now became the y, and the y became the x. All right, so the coordinates are interchanged. That's to be important. Okay. The other thing that we saw in our lessons when we talked about inverse functions was that a function has an inverse, and that was one of the lessons we did here. A function has an inverse if it is one-to-one. So if it's a one-to-one function, it has an inverse. And we talked about the horizontal line test. So if you need to go back and review that lesson, you can. So if a function passes a horizontal line test, then it will have an inverse function. And remember when we talked about I'm just going through the lesson that we did. So then we talked about finding the functions algebraically, and that's what we're going to use today. So remember, we replaced f of x with y, and then we interchanged the variables, and then we solve for y. And then what we end up with for y is our inverse. Okay? And so that is a kind of review of what we did last time. Now, just to remind you very quickly, okay, just to remind you the definition of a one-to-one function. So remember, a function, first of all, has to be a one-to-one function. First of all, it has to be a function. Okay, so we saw that. So we saw that if you have a function, then we can determine if it's one-to-one. Not all of them are one-to-one. We saw that. Not all functions are one-to-one. Like the quadratic functions are not one-to-one unless we restricted the domain. And we saw an example of that as well. But a one-to-one function is a function in which for each y coordinate, there is exactly one x coordinate. Now, don't confuse that with the definition of a function. A function is a relation in which for each x coordinate, there's exactly one y coordinate. So notice that the variables are interchanged. Okay? All right, so let's go ahead now and look at some examples where we're going to find the inverses of a function, and sometimes it'll say symbolically, and I can't, symbolically, symbolically, or algebraically. Okay? All right. Now, before we begin, let's look at this example. Sometimes before you're giving an equation, you may be given a set of ordered pairs. So I just want to show you what to do in that case if you're given a set of ordered pairs. So here's an example. Number 1. Suppose that your function is this set of ordered pairs. It's -3, 4, 7, -5, 2, 6, and 3, 8. All right? And first of all, keep in mind that if we're going to talk about inverses, then first of all, it has to be a one-to-one function. And remember, this is a one-to-one function. Remember how we talked about that. This is a one-to-one function because for each y coordinate, there's only one x coordinate. So when y is 4, my x coordinate is -3. When y is -5, my y coordinate is 7. When y is 6, my x coordinate is 2. When y is 8, my x coordinate is 3. So notice that for each of these y coordinates is exactly one x coordinate. So this is a one-to-one function. So since this is a one-to-one function, since this function is one-to-one, it has an inverse. Okay? And notice that to find the inverse of a finite set of ordered pairs, remember our discussion where the inverse undoes what the function does. So you're just interchanging the coordinates. So basically all you're going to do is interchange these coordinates. So you're going to say f inverse. Here's, look at the notation. That notation's important. Remember, this is f, this is your function, this is your function, this is f inverse. So this is the inverse of that function. So you must say f inverse. And again, don't confuse that with f to the -1 power. Don't say f to the -1 power. That does not mean the same thing as 4 to the -1 power. In a previous course, 4 to the -1 power means 1/4. That's not what this is, okay? So don't confuse that with this, with these two ideas. That's not the same. So f inverse, all you can do is just interchange the coordinates. So -3, 4 becomes 4, -3. 7, -5 becomes -5, 7. 2, 6 becomes 6, 2. 3, 8 becomes 8, 3. And that's all you do. So when you're given a finite set of ordered pairs, you're just interchanging the coordinates. So number 2, let's say we had this. You had 8, 6, -2, 5, 3, 9, and 7, 2. All right, so suppose we had that. Now keep in mind that the directions does say find the inverse. So all of these will be one-to-one functions. So all these examples are functions. In particular, they are all one-to-one functions. And you can see that for when x is 6, you only see one y value. I'm sorry, one x value. When y is 5, there's only one y value, x value. When y is 9, there's only one x value. And when y is 2, there's only one x value. So that's a one-to-one function. All of our examples will be one-to-one functions because that's the only way it will have an inverse. It has to be a one-to-one function, okay? So then, here, if this is f, so you say f inverse will equal, and all you do is interchange the coordinates. Just make sure you use set notation. So 8, 6 becomes 6, 8. So remember, you're just interchanging the coordinates. -5, 2 becomes 5, -2. 3, 9 becomes 9, 3. And 7, 2 becomes 2, 7. Okay? All right. Now, so given a set of ordered pairs, it's very easy to find the inverse. Okay, let's look at number 2. So the next set of directions will say find the inverse algebraically. So find the inverse algebraically. Find the inverse algebraically. Okay, so let's look at some examples of that. Now let's remind ourselves about the steps. So let's talk about the steps first, and these are the same steps from a previous lesson, except this some of these problems will be a little bit more involved than the previous lesson. Okay, so let's remind ourselves about the steps. So the first thing, remember, step 1 is to replace f of x with y. We know that that's easy to see because in all of our discussions, f of x meant the same thing as y. Then we're going to interchange the coordinates because remember, the inverse undoes what the function does. So that's where we interchange the coordinates. So you replace x with y and y with x. Once you do that, then you're going to solve for y. And then once you solve for y, that is your inverse. You replace that y with that notation f inverse. Okay? All right, we're going to start with a simple example, as an example similar to what we had in the previous lesson. So it's going to be a linear function. So let's suppose we had f of x is equal to negative 3x plus 4. Okay. Now, linear functions are easier to understand because it has a few steps. So notice that what this function does is it takes x, and it multiplies by negative 3 and adds 4. The inverse will subtract 4. It does the opposite. So the inverse subtracts 4, and then see this multiplication, then divides by negative 3. So you're going to see that in the answer when we get to it. But always follow directions. It does say do this algebraically. So you have to show those steps. That's important. Follow the directions. Okay, so then step 1. So S1 means step 1. Step 1, you're going to replace f of x with y. So y equals negative 3x plus 4. Step 2. You interchange the coordinates. X equals negative 3y plus 4. Step 3. You solve for y. So we're going to subtract 4 from both sides. So I get x minus 4 equals negative 3y. And then you get y by itself, divide by negative 3, and you're done. That is your inverse. So y equals x minus 4 divided by negative 3. So step 4, and put step 4 here. Step 4, f inverse, is this right here. So it's equals x minus 4 divided by negative 3. Okay. Now, first of all, let me remind you, and we're not going to do this in all the problems, but remember, before we can talk about finding the inverse of a function, you got to make sure that that function is a one-to-one function. So notice that this is a one-to-one function. I want you to see this. This is a one-to-one function because if you were to graph it, and we're not, but it has a negative slope, right? And the y-intercept is 4, and so you go down. Well, actually, let's go ahead and graph it. So the y-intercept is 4, the slope is negative 3. So you go down 3, 1, 2, 3, and then so you go down 3 and then to the right 1. So notice that it's a decreasing function. The slope is negative, so it should be falling, and it passes the horizontal line test. Okay, so it's a one-to-one function, and there's the inverse. Okay, and in another lesson, you're going to learn how to graph those inverses, and you're going to notice in a lesson coming up that when you graph them, you're going to use the idea of the y equal x line to help you graph it, because inverse functions are going to be symmetrical about the line y equal x. You don't need to know that here, but that's going to come up later. Okay, let's look at number 2. Number 2, let's suppose we had a cubic function this time. And let's call it g of x. So g of x equal x cubed minus 7. And that's also a one-to-one function because, remember, the ones that we have are going to be easier to kind of think about the graph. So you take your parent function x cubed and you shift it down 7 units. And so basically the graph looks something like this. So let's say this is negative 7 right here. So it looks something like this. Okay? So that's the graph of g of x. It's a very... it's not a good graph, but it'll work for our purposes. And so notice it passes the horizontal line test. My question becomes, do you have to do this all the time? No, because I'm already telling you, if I'm telling you to find the inverse algebraically, then it's going to be a one-to-one function I'm going to give you. Okay? All right. So the first thing we do, step 1, is replace g of x with y. So y equals x cubed minus 7. Then you interchange the coordinates. Step 2, interchange the coordinates. X equals y cubed minus 7. And then you solve for y. Okay, so let's think about how to solve for y. So we got to get y by itself. First of all, I'm going to add 7 to both sides. So step 3 is to solve for y. So you add 7 to both sides. And so you get x plus, that's a 7. Add 7 to both sides. So x plus 7 equals y cubed. Now, to get y by itself, you see you're cubing it, right? So the opposite of cubing is to cube root. So we're going to take the cube root of both sides, and that's it. So the cube and the cube root will do each other. So you get y equals the cube root of x plus 7, and that's your inverse. So step 4, you're going to say g inverse. Make sure you use the correct notation, g inverse. This was g of x. So g inverse is going to be the cube root of x plus 7. Okay, let's look at number 3. All right, number 3, let's suppose we had this, number 3. All right, so number 3, we have f of x equals x squared plus 6. Okay, now I'm going to add something to this, but let me just remind you. So recall x squared plus 6, when you graphed this in a previous lesson, when you did transformations, that was a quadratic function, right? And you took your parent function, you shifted it up 6 units. So just to remind you, the parabola, the graph of this looked like this. And so you know that it does not pass the horizontal line test. So that in itself, this in itself is not a one-to-one function. It's a function, it's not one-to-one, okay? But we can restrict the domain. So you'll also see something like this. So notice the domain for this function is all real numbers. So if you look at the domain of all real numbers, this is not a one-to-one function. But if I take this piece away, if I take that piece away and only look at this piece right here that has domain from 0 to infinity, then that part is a one-to-one function. And that's what you're going to see here. So the directions will say something. So the problem will say f of x equals x squared plus 6, where x is greater than or equal to 0. And that's what this is. So whenever you graph this, you only graph in this piece here. So the graph looks like this, just to let you know, the graph looks like this. And so that is a one-to-one function. So this, with the restriction, is a one-to-one function. This without the restriction is this, and that's not a one-to-one function. So this is why we have to restrict the domain. Okay? All right, so let's go ahead now and do our steps. So now this is a one-to-one function because I restricted the domain. So note, this is a one-to-one function. And when I say this, I mean this. This is a one-to-one function because I restricted the domain. All right, so I restricted the domain. So I'm only looking at the domain from 0 to infinity. So from 0 to infinity, that's this right here. So it does pass a horizontal line test, so it is a one-to-one function. Okay, so step 1, replace f of x with y. So y equals x squared plus 6. Step 2, interchange the coordinates. So when I interchange the coordinates, I get, so that's step 1. Step 2, interchange the coordinates, I get x equal y squared plus 6. Okay. Step 3, solve for y. So subtract 6 from both sides. So I get x minus 6 equals y squared. All right, now be careful. Remember when you solved an equation in a previous lesson and you had that y squared and you were trying to get y by itself, you take the square root of both sides. Remember you got that plus or minus? Okay, but remember though, you don't do the plus or minus here because you restricted the domain. So I want you to notice, you see right here where we had that x was greater than or equal to 0? When I interchanged the coordinates, this became y is greater than or equal to 0. So that's your range. So when I take the square root of both sides, I'm only looking at positive. See, greater than or equal to 0 means positive. I'm only going to take the positive square root. Okay, so that's important. So I'm going to take the positive square root, not the negative. See, y is positive. So when I take the square root of both sides, y is going to be the positive square root of x minus 6. Okay? All right, so step 4, you're going to say f inverse is going to equal the square root of x minus 6. Okay? All right, number 4. Let's suppose we had this function. G of x is equal to 9 divided by x. G of x equal 9 divided by x. Okay, so if you were to look at the graph, this is a rational function, and so remember you can't have 0 in the denominator of a rational function. So this rational function has a vertical asymptote at x equals 0. Now, all that's not important to note to do this, okay? All you have to know is that this is going to be a one-to-one function, and it is one-to-one, and you just go ahead and do your algebraic steps. So step 1, replace g of x with y. So y equals 9 divided by x. Step 2, interchange the coordinates. X equal 9 divided by y. And then now all you do is get y by itself. All right, so remember you have a fraction here, right? So the LCD is y. So to get y by itself, the way you need to do this is, since the denominator is y, you're going to multiply both sides by y. Okay, so I get, let me show you. So I can say times y times y. So I'm going to go ahead and, instead of saying y, I'm going to put xy. So xy equal, and then the y's divide out, 9. And remember, we're trying to get y by itself, right? So now I'm going to divide both sides by x because I'm multiplying by x here. And so therefore, the x is divided out, and you get y equal 9 divided by x. And that is your inverse. So this was step 3. And step 4, you're going to say g inverse of x is equal to 9 divided by x. Okay? All right, so that is number 3. Okay, number 4 rather. Okay, let's look at number 5. Now number 5, let's suppose we had this. Let's do another rational function, number 5. Okay, number 5. You have g of x is equal to 1 divided by x minus 5. Okay, so we have this function. You just need to know that it's a one-to-one function. Okay, so assume it's a one-to-one function, and we're gonna find this inverse. So step 1, remember, is to replace g of x with y. Okay, so we get this. Step 2 is to interchange the coordinates. So we get x equal 1 divided by y minus 5. And now step 3 is to solve for y. Okay, so you got to remember some things that you had in previous lessons regarding solving rational equations. So let's talk about solving for y. So I'm going to go ahead and rewrite this over. I'm going to rewrite this as x over 1 equal 1 divided by y minus 5. Okay, so notice first of all, you can think of this as a proportion, and so you can cross multiply since you only have one rational expression equal to another. Many of you probably will not have seen this, so probably what some of you are going to do is you're going to say, well, the least common denominator is y minus 5, so I'm going to multiply both sides by y minus 5. Okay, that's probably what you're going to do, just like this. And so you get x times y minus 5, just like that, equal, and these y minus 5s divide out, equal 1. And notice you get the same thing as if you were to cross multiply, since I have a proportion here. So x times y minus 5 equals 1 times 1, which is 1. Now, you got to get y by itself, so you're going to distribute first. So you get xy minus 5x equal 1. Okay? Now, notice there's only one term with the variable y in it. You've got to get y by itself, so let's bring this term to the other side, since it does not have the y in it, the factor y. So you add 5x to both sides. Combining like terms, you get xy equal 1 plus 5x. And then finally, to get y by itself, right now you're multiplying by x. The opposite is divide by x. So these x's divide out, so you get y equal 1 plus 5x divided by x, and there's your answer. So step 4, you're going to say g inverse of x is this, 1 plus 5 divided by x, 5 times x divided by x. All right. Now be careful. You see, some of you have a habit of canceling out these x's, but you got to be careful. This x here is not considered a factor of the numerator. The numerator, you see, there are two terms there. So when you cancel out these x's, you're forgetting about the fact that this term here is also being divided by x. So be careful. You got to know when to reduce, when can you cancel out, when can you factor, when can you reduce, things like that. All right, so there's number 5. Notice number 5 was a little bit more involved because you are dealing with a rational function. So remember, these are rational functions here. Rational functions. Those are a little bit more involved in terms of finding its inverse. So let's do another one. Let's do another rational function. So this is going to be number 6. So number 6. All right, now watch the steps. So you have h of x is equal to 4x divided by x plus 7. So h of x is equal to 4x divided by x plus 7. So let's go ahead and do our steps algebraically. So step 1, replace h of x with y. So y equal 4x divided by x plus 7. Okay. Step 2 is to interchange the coordinates. So wherever you see a y, you replace x. Wherever you see an x, and there are 2 places here, you replace y. So step 2, you're going to say x equal 4y divided by y plus 7. Since I have a rational equation, I'm going to multiply both sides by the LCD. And the LCD is y plus 7. So you're going to say this. So step 3 is where you're going to solve for y. So here's the process. Let me go ahead and rewrite this over. I'll leave some room here. And then 4y divided by y plus 7. So you can multiply both sides by y plus 7 times y plus 7, just like that, okay? Then getting rid of the parentheses here, you can distribute. I get x times y plus 7 times x equal, these y plus 7's divide out. That's the whole point of multiplying by the LCD, and you get 4y. I want you to notice though, see there are 2 terms with the variable y. In the previous problem, you got to be able to see the differences. In the previous problem, when I got to this point here, there was only one term with the variable y. And then it was very easy to deal with. Okay? Here, there are 2 terms. So 2 terms with the variable y. There are 2 terms. So you got to bring all the terms that involve y to one side of the equation, just like we did here. There was only one term. So since it was already on the left side, I just brought this to the right side. And now notice when I got to that point, the right side did not have any factors of y. It was only the left side, and then I could easily solve for y. Over here, they're on both sides of the equal sign, so I'm going to bring them all to the same side. So since this side here contains 2 terms and only one of them has a variable y, has a factor y, I'm just going to bring it to the other side. So I'm going to have this. I'm going to subtract xy from both sides, just like this. Okay? And so these add up to be 0. So I get 7x equal 4y minus xy. Okay. Now, let's see if you remember how to deal with something like this. Remember, you got to solve for y, right? And so in a previous course, last semester, you spent almost quite a few months talking about factoring. And you did some factoring in this course as well in some of our concepts. So notice that these 2 terms have a factor of y. So I can factor out a y. So I get 7x equals y times 4 minus x. Okay? So y times 4 is 4y, y times a negative x, xy. And all you do is to get y by itself, right now you're multiplying by 4 minus x, right? So the opposite of multiplying by 4 minus x is to divide by 4 minus x. And these 4 minus x's as factors divide out. So you get y equal 7x divided by 4 minus x, and you're done. So step 4 is to tell me what my inverse function is. So this is h inverse. H inverse of x is this. It's 7x divided by 4 minus x. Okay? So again, notice that in number 5, when you multiply both sides by the LCD, only one term involved the variable 5. In number 6, 2 terms involved the variable y, and they were on separate sides. So you had to manipulate this to get them all on the same side, to get the terms involving the variable y on the same side, and then you had to use factoring. So you had to factor out the y. All right, that's number 6. You want to do another one? Let's do another one with rational. Okay, number 7. Let's do another with rational. So number 7. Number 7, let's say you had k of x equal 3x plus 2 divided by x minus 5. And you want to find the inverse function. So this is a one-to-one function. Okay, it's a rational function. If you're a graphic, you would see that this is that it passes the horizontal line test. But you don't have to do that here. You're automatically given that it's a one-to-one function. Okay, so you want to find its inverse. So step 1, replace k of x with y. So y equals 3x plus 2 divided by x minus 5. Okay. Step 2, you interchange the coordinates. So step 2, x equal 3y plus 2 divided by y minus 5. All right, you interchange the coordinates. So y becomes x, your x's become y's. And then notice I have this rational equation, so you're going to multiply both sides by the LCD. And so step 3 is where you're gonna do that process, and you're going to solve for y. So let me go ahead and rewrite this over, leave some space here. So 3y plus 2 divided by y minus 5. All right, so I'm going to clear the fractions. We'll multiply both sides by the LCD. So I'm going to say times y minus 5 times y minus 5. Okay? Now on this side, let's go ahead and distribute. So I get x times y minus 5 times x, right? Equal, these divide out, and you get 3y plus 2. So just like in number 6, I have two terms with the variable y, but they're on separate sides. So I've got to somehow bring them to the same side, either to the left or the right. Does not matter. Does not matter. So since I have two terms with the variable y and two terms without, let's just go ahead and bring the terms with the variable y to the left this time. So let's go ahead and subtract 3y from both sides. And so I get xy minus 3y, okay? Xy minus 3y minus 5x equal, this is 0, 2. Now, this doesn't have the variable y, so let's bring it to the other side. So I'm going to add 5x to both sides and combine like terms. These are like terms, these are not. So don't say this is 7x. You're in college algebra now. You need to know that. That's not 7x, that's 2 plus 5x. So you get xy minus 3y equal 2 plus 5x. And now, do you remember what to do now with this? There are y's in both terms. You got to factor out the y. So you get y times x minus 3 equal 2 plus 5x. And then notice you get y by itself. Right now you're multiplying by x minus 3, right? And the opposite of multiplying by x minus 3 is to divide by x minus 3. So divide by x minus 3, just like this. The x minus 3's divide out. X minus 3 divided by x minus 3 is 1. Y times 1 is y equal 2 plus 5x divided by x minus 3. And there's the inverse. So the inverse, you're going to say k inverse of x. So this is step 4. Step 4, k inverse of x. So step 4, remember, is where you replace y with the inverse notation. So it's going to equal 2 plus 5x divided by x minus 3. All right, so that's number 7. Okay, let's look at number 8. Now, number 8 is going to be a different kind of function. So number 8 is this. You have f of x equals the cube root of x to the 5th plus 7. Okay? All right, so you have this function. It is 1-to-1. So since you're told it's 1-to-1 function, you can find the inverse. I'm going to do this algebraically. So step 1, replace f of x with y. Y equals the cube root of x to the 5th plus 7. Okay? Step 2, interchange the coordinates. So y becomes x becomes y. X equal the cube root of y to the 5th plus 7. All right, now here's your obstacle. You're like, well, how to get y by itself? Because y is within all of this other stuff. All right, well, you got to think about what you have. So notice, you see this y that you're looking for, right? So I'm looking for this y right here. I want to get y by itself. So I got to get rid of everything else. So right now, listen to the order that you see it. Y is being raised to the 5th. That's the first thing you see. Second thing you see is now it's being added to 7. The third thing is you're going to take the cube root of that. Okay, to get y by itself, you do the opposite of the order. So this was the last thing I said. So when I do the opposite, this will be the first thing you're going to get rid of. So you can get rid of the cube root first. So the opposite of cube rooting is to cube both sides. So I'm going to rewrite this over. All right, so to get rid of the cube root, you're going to cube both sides, just like this. So you get x cubed equal the cube and the cube root into each other, and you get y to the fifth plus 7. Okay? All right, now remember, you're trying to get y by itself, right? So right now I'm raising to the fifth, and I'm adding 7. Whenever you're solving for y, you do the opposite of what you said. So you're going to get rid of 7 first, and then we're going to get rid of the 5. So the opposite of adding 7 is to subtract 7. So I get x cubed minus 7 equal y to the fifth. And then finally, to get y by itself, right now you're raising to the fifth, right? So the opposite of raising to the fifth is to take the fifth root of both sides. So I'm going to write this over. So you can take the fifth root, notice the index 5, take the fifth root of both sides. And so the fifth root and the exponent of 5 undo each other. So you get y equal the fifth root of x cubed minus 7. Okay? And so that is your inverse. So f inverse then will be the fifth root of x cubed minus 7. So we are step 4. Step 4. And this right here, when you solve for x, that was step 3. When you solve, solving for y. Okay, but notice the process that you went through. All right. So let's look at another one. All right, so it's going to be number 9. So let's suppose we had this for number 9. Let's suppose we had g of x is equal to 4 plus the square root of x plus 3. All right, so let's suppose we had that. So we have this function, it's 1 to 1, so I can find its inverse. So let's talk about the inverse. So step 1, you're going to interchange the coordinates. So you're going to rewrite g of x as y, so y equal 4 plus the square root of x plus 3. Okay, so then you're going to interchange the coordinates. So x equal 4 plus the square root of y plus 3. All right, now remember, you got to get y by itself now. So the next step is to solve for y right here. You're going to try and get this y by itself because that's the only y that you see. So let's think about this. So right now, see this y? I am adding 3, then taking the square root, and then adding 4. To get it by itself, you do the opposite order. So you're going to subtract 4. Okay, so let's do that first. So you can subtract 4 from both sides. So let me go ahead and rewrite it first. So you can subtract 4. So I get x minus 4 equal, this is 0, the square root of y plus 3. Okay, so let's think about what we have now. Again, we're trying to get y by itself, right? So right now I'm adding 3, and then I'm going to take the square root of that. So notice I said the square root last. So you're going to get rid of the square root first now. So to get rid of the square root, you're going to square both sides. You're going to raise both sides to the index power. So x minus 4 equal the square root of y plus 3. You square both sides, just like this, just like that. And so you're going to get x minus 4 squared equal the square and the square root undo each other, y plus 3. Now don't multiply this out. Leave it like this. Okay, leave it like this. All right, and then you're going to get y by itself, and finally you're going to subtract 3, and so you get x minus 4 squared minus 3 equal y. And notice that this is vertex form. Remember, that's vertex form. Leave it like that. Don't multiply it out. Leave it like that. And there's your inverse. So we're going to say step 4, g inverse of x is going to be x minus 4 squared minus 3. All right. And remember, be careful. So you may say, well, this is a quadratic function. I thought a quadratic function was not to 1 to 1. Yeah, but remember though, when you look at the domain here, the domain, remember, you can only take the square root of a positive number or 0. So the domain here was any number greater than or equal to -3. right? And so when you go through the process, when you go through, and by the way, the domain was any number greater than or equal to 3, and the range, when you graph this using transformations, you will see that the range would be y is greater than or equal to 4. And so notice when you interchange the coordinates, the y became x, so y is greater than or equal to -3, and the x became y, and the y became x, and then x is greater than or equal to 4. So notice that if I were to graph this right here, that would look like this. So I take the parent function, I move it to the right 4 units, and then down 3. So 1, 2, 3, 4, and then 1, 2, 3. And then notice that all I'm looking at is actually this piece. So this right here is really this. Okay? So don't get thrown off when you start out with a square root function, because the square root function is 1-to-1, and you end up with a quadratic function. You may say, well, how is it 1-to-1? Because it's quadratic. Well, that was because when you look at a square root function, you have a restricted domain anyway. And so both of these, the domain and the range, play itself out when you get to that point. So notice that the domain here is any real number greater than or equal to 4, which is see, this is 4. So you see, notice from 4 to infinity is your domain. So don't get thrown off when you get to this quadratic function as an inverse. All right, some students do, and so they get blown away when they see this quadratic function, and they're like, well, how can that be the inverse of something when it's not 1-to-1? Okay, let's do one more. We have time for one more. Let's do one more. Let's talk about this one. This will be number 10. Let's do this one. Let's see how far you can come with this one. So this will be 8 divided by x cubed minus 2. So again, we have this rational function, except in the previous rational functions, the denominator was linear. This is cubic. Same idea. Let's see how far you can get. So replace g of x with y. So y equal 8 divided by x cubed minus 2. Step 2, to interchange the coordinates. So x equal 8 divided by y cubed minus 2. And then step 3 is to solve for y. But notice I have this rational equation, right? So you're going to multiply both sides. I'm going to rewrite this over. So you're going to multiply both sides by the denominator, by this right here. So you multiply both sides by y cubed minus 2. So y cubed minus 2. Okay? And then you can distribute. So I get y cubed times x minus 2x, okay, so that's this right here, equal, these divide out, 8. All right, now notice that this is the only term that has that y in it. So I'm going to bring this 2x to the other side, and that should be equal 8 here. So I'm going to add 2x to both sides, and so this is 0. So I get y cubed times x equal 8 plus 2x, correct? To get y cubed by itself, right now I'm multiplying by x, I'm going to divide by x, okay, just like this. The x is divided out here, so I get y cubed equal 8 plus 2x divided by x. So that's where I'm at. Now remember, I'm trying to get y by itself, right? So right now I'm cubing y. What is the opposite of cubing? The opposite of cubing is to cube root. So I'm going to rewrite this over. So you're going to take the cube root of both sides, just like this. Make sure it looks like you're taking the cube root. See how I extended this down further to make sure that that x was under that radical? Okay. So you take the cube root of both sides, the cube root and the cube undo each other. So you get y equal the cube root of 8 plus 2x divided by x. And there's your inverse. So step 4, you're going to say g inverse of x is the cube root. We're going to move this over. The cube root of 8 plus 2x divided by x. All right. And so those were, it's not really that bad finding the inverse of a function algebraically. Uh, just know the different types of functions we had. We had rational functions. We had finding the inverse of um, radicals, square root functions. Um, we had cube roots, radicals again. We had rational. Okay, so those were the types. Those are the more common. See, rational, the more common types. We had quadratic. Now remember, when you start out with a quadratic function, you have to be told that it is what the restriction is. Okay, so you have to be told it's 1-to-1 because in itself, a quadratic function is not 1-to-1, right? Okay, so it is 1-to-1 when you restrict the domain, when you're only looking at part of the parabola. Okay, and then we looked at linear. Okay, so you have a few more examples to go through to get you through this first part or one of the parts of the study on inverse functions. So that is going to be, oh, here we go. I'm sorry. We also, don't forget, we also had um, where you're given, a finite set, a function that's written in finite set form. It is 1-to-1, and you have to find its inverse. Okay? So that is the end of this part.